Carlos Hernandez and Tim Gagnon, two fantastic space artists. They both have different techniques and different things that they do, but their heart is, I think, very super similar. They both love space. They fell in love with space when they were young, just like all of you guys, and found a way to take what their talents and natural kind of abilities were and meld that in with their true talents and stuff. So without further ado, I'm going to spotlight you, Carlos, and we're going to begin with you. We're going to share your screen. Again, guys, you're going to take a look at this, and just like I did, and it's like, oh, that's a picture of something. No, what you're going to be seeing today as he shows us a lot of these things are all the things that Carlos has drawn himself. So thank you so much for being here, and take it away, Carlos.
Well, Janet, thank you for inviting myself and Tim for this show. And I hope that everyone gets to enjoy our lecture. This is the first picture that you're showing is a painting that I did of the planet Saturn with its ring system from one of its moons called Mimas. Now, everyone may know Mimas as the Death Star moon because when the Voyager spacecraft and later the Cassini orbiter imaged the moon, it had the appearance of the Death Star in the Star Wars movies. But the large crater is called Herschel, and it's got this huge peak in the middle. And the painting is if you were standing in the crater looking at towards Saturn from the center of that crater.
Gorgeous, gorgeous. All right. Oh, again, when the computer doesn't, all right, sorry guys, oh, there you go.
Well, the universe is vast and it's extraordinary. We've seen incredible images obtained by the Hubble Space Telescope, and this is one of them of the Edge-on galaxy, the Sombrero galaxy in the constellation of Virgo. And here you can see the dust lanes in the middle, and our galaxy would look similar to this one if you looked at it from Edge-on, but it's a little bit smaller than the Milky Way. But it's a beautiful example of a galaxy out there among billions of other galaxies. Now this is the another Hubble image, Hubble Space Telescope image of the famous pillars of creation. It's showing these columns of gas and dust within this nebula in the constellation of Aquila that is actually the birthplace of stars. Where you see that glow along the edge of the columns, that's actually where stars are born within that area. And as time goes by, the gas disperses and then the stars appear, and that's how stars are truly born in space. But it's a spectacular image of the Eagle Nebula in the constellation of Aquila.
But who out there, just by polling or raising your hand of some sort, thinks that this is a picture? Or do you think Carlos painted it?
I think it's a picture.
Oh, do you want to tell him what it is?
No, this one is actually a picture.
Oh, this is a picture. Okay. So I'm just, because later on you might find yourselves a little bit, I'm going to make you just a little bit larger there. But again, you might find yourself going, is that a picture or did he paint that? All right. So just checking to make sure you're paying attention.
Now this is a painting that I did of the sun, of our sun, and it shows a very active surface and huge prominences along the limb. And I'm showing this because of an example of an average star in our galaxy or in the universe. It's a yellow dwarf star. It's a very important star for us because it gives us life, it gives us heat and energy. But it's an incredible source for the Earth, and it's an example of an average star in our galaxy. This is a picture of the Hubble by the Hubble Space Telescope, and it's a picture of the Helix Nebula in Aquarius, and it's the outer shells of a dying star that expanded away from that star at the end of its lifetime, and that's the tiny white star at the center is a white dwarf star, and our star, a yellow average star, will become a white dwarf in over 4.6 billion years. And this is what the sun would look like if you were around at that time.
Wow.
Now, there's many stars in the galaxy, in the universe, that are much larger than our sun. One of these is the red supergiant star Betelgeuse in the constellation of Orion the Hunter, and it's the upper left-hand shoulder of the constellation. And it's normally the 10th brightest star in the sky, although it does dim at times, like it did recently. This star, if you were to place this supergiant star where our sun is, it would go, the outer surface of of this star, the photosphere, would extend beyond the orbit of the planet Jupiter. And here's Jupiter to show that it's going to it, or it could go beyond. But it's just an example of the different size stars and the incredible sizes of stars within our galaxy and other galaxies as well.
And guys, what makes this photo so profound is that you could fit 11 Earths across the front of Jupiter and still have room to spare. And Jupiter makes up, 2.5 times the mass of everything in our solar system. So that is one incredibly large sun. Oh, so good.
Yeah. And at the end of a star as large as Betelgeuse, it collapses to a great degree to either what's called a neutron star, or in this case of my painting, a black hole where no light or particles can escape. And you can see the black hole in the upper right corner devouring or taking in a star that got too close to it. And that's what a black hole does. It takes in all the matter around it. And there is a gigantic supermassive black hole at the center of our galaxy and many other galaxies that behave this way. Now, our planet is a wonderful, it gives us life, it gives us everything. And it's a terrestrial planet, it's a rocky planet, it's about 8,000 miles in diameter, 3/4 covered by water. And it's one of the few places, well, it's the only place that we know for certain that contains life in the universe. Now, other places may contain life, but this is the only place that we know for sure that has life. But it's the densest planet in the solar system, and it's our home.
Excuse me.
Uh-huh.
I have a quick question. So you were talking about how there's a big black hole in the center of the Milky Way and lots of other galaxies. In the case of the Milky Way, is that why it looks like a swirl? Because the matter is being sucked in, or?
No, actually, the swirl, and you're describing what's called a spiral galaxy. Our Milky Way is actually a barred spiral galaxy, and there's many different types of galaxies, but our galaxy is a spiral galaxy. The closest, one of the closest galaxies to us, or the closest, the Andromeda galaxy, is another spiral galaxy. So if you were to look at the Andromeda galaxy, that's what our galaxy would look like from the outside. Now, the spiral, or the twisting arms of the galaxy, were formed by the motion of the stars and the dust and gas within our galaxy and other galaxies, created a long time ago. But the huge black hole at the center of the galaxy does rotate, or does revolve and absorb matter, but it's not the reason that our galaxy spins or other galaxies spin, even though they also have giant black holes at their centers.
Thank you for that question. Now, I see a good bit of chat, and I have to tell you that in this presentation, I can't read them all. Does anybody else have a question before we go on?
No.
Okay.
Okay.
I'm keeping an eye on it.
All right, good.
Now, sometimes we're fortunate that we can look in the skies and see what's called a lunar eclipse. In this case, a total lunar eclipse when the moon enters the shadow of the Earth, um, and it can turn into a red blood color depending on what part of the shadow it goes into. This is an example of a total lunar eclipse that I observed in January of 2019, and it turned a very dark red blood color. And these are my paintings showing the development or evolution of the eclipse over time as the shadow crossed
Excuse me, Mom.
of the moon.
Go ahead. Ander, make sure you're muted.
Mhm.
All right, we're good. Go ahead.
Okay. But this is a wonderful thing that if anyone can actually uh, witness this, total eclipses or lunar eclipses are fantastic to observe. Now, looking through my telescope, I have a 9-inch or 23 centimeter combination lens mirror telescope called a Maxitov Cassegrain. And through that telescope, I look in the eyepiece and I make drawings of what I see. And this is a drawing or a painting of a crater. Its name is Petavius, and it's on the day-night separation, or what we call the terminator. And a lot of times when a crater is such a large one like this one is on the terminator, you can see a lot of detail because the shadows are very long, so the detail is exaggerated. But this is an example of a painting of a lunar crater that I made.
So beautiful.
This is a drawing of another lunar crater by the name of Clavius in the southern hemisphere of the moon. And it's actually almost a giant basin because it contains many craters within it as well. But it's one of the most recognized craters on the moon. And it's very, very close to the Ray crater Tycho. And it's a spectacular crater to observe through a telescope.
Just gorgeous, gorgeous.
Now, this is a painting of the Apollo 11 Saturn V rocket that launched to the moon in July 1969, carrying astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins. And they were the first men on the moon, Buzz Aldrin and Neil Armstrong. And this is a painting of the Apollo 11 Saturn V rocket based upon a photograph of the launch of the Saturn V rocket that I produced.
I mean, I look at this and it looks just amazing. Just what an artist you are.
Thank you.
That didn't look like a painting at all. That was so amazing.
Well, thank you. You should prepare yourself for the space launch system that's coming up, because that's going to be even more spectacular than the Saturn V. This is a painting that I did of Buzz Aldrin on the moon next to the lunar lander, imaged based on a photograph obtained by Neil Armstrong. And as you can see, the moon is a very bleak environment. There's no atmosphere on the moon. And also that's a reason why, if you look at the shadows of the astronaut and the lunar lander, the shadows are very sharp and dark. Whereas on Earth, the shadows are more muted because of our atmosphere, but there is no atmosphere on the moon.
And again, guys, take a good look at that kind of dark and light and explain to them why the shadows are so kind of like more prevalent, or I don't even know what the word might be, but they're definitely more stark in quality.
Yes, sharper defined they are.
Yeah.
Yes.
But that's because the reason why the shadows on the moon and other objects that don't have extensive atmospheres like ours do, our planet, is because that's why you see the shadows so dark and intense, because there's no dispersion of the shadow. And that's why the shadows are like that.
Just gorgeous.
Now here's a painting I did of future astronauts exploring what's called a lava tube over the surface of the moon. And these also exist over the surface of Mars. And the importance of lava tubes is these were created from the outflow of volcanic lava billions of years ago when the moon was very active. And as the lava receded, it left these depressions, these holes, these lava tubes. And the importance of them is that in the future, astronauts may be able to use these lava tubes to establish bases because it will protect them from radiation from space if they were on the surface of the moon or if they were on the surface of Mars. Because our magnetic field, the Van Allen belt, protects us from radiation, whereas on the moon and Mars has a very weak magnetic field, but the moon has no magnetic field or hardly any. And the astronauts may be able to use these lava tubes in the future to establish a base.
I love it. I want to go there right now.
Well, here's the fourth planet from the sun, Mars, the god of war. And these are Hubble images obtained by the Hubble Space Telescope. The one on the left, and both of them were obtained in 2001. The one on the left shows the dark and light areas on Mars. The light areas represent desert, and the dark areas are also within the desert, but they're exposed volcanic bedrock that early astronomers believed to be seas or containing water. So they named them after bodies of water, mare, but they're actually exposed bedrock, volcanic bedrock, over the surface of the planet. And you can see clouds over the North Polar region and the South Polar region as well. And then the image on the right is Mars experiences planet-wide dust storms at times. And this is an example in September of 2001 when a planet-wide dust storm covered the entire planet.
Wow.
Now, on July 30th this year, we launched a very special Mars rover named Perseverance, and it is scheduled to arrive at Mars on February 18th, 2021. And it's over a 7-month period. It's going to be going through space, heading towards Mars. And then finally, on February 18th, it will encounter the atmosphere of the planet Mars. And it's the rover and the sky crane are within this capsule, and it includes the heat shield that protects it as it enters the atmosphere, and it increases in temperature, so it protects the contents. And then as the capsule enters the atmosphere further down, the heat shield is removed, and then the rover and the sky crane are lowered. And during this time, it's a period of 7 minutes, and it's known as the 7 minutes of terror because we cannot communicate with the rover. But luckily, other rovers, other missions have done this, and we've been very fortunate.
That is going to be so fun. And especially when Perseverance gets there and after it backs away, and then Ingenuity takes a little run for the first time ever with that helicopter.
That is going to be exciting, yes.
Whoops. Come on, computer. There's always, sorry guys. Oh, there he goes.
This is a painting that I did of showing the Perseverance sky crane on top and the actual Perseverance rover beneath it, connected by cables, as it lowers the rover onto the surface of what is Jezero crater in the northern hemisphere of Mars, just above the equator, where it's going to land and explore. And the reason it uses a sky crane is because this rover is very large. It's about the size of a small vehicle. And in the past, we didn't need to do this. But since these rovers are getting larger and more complicated, more complex, we need something to be able to lower them onto the surface of the planet in a safe manner. And when it lowers the rover onto the planet, the sky crane will fly away from the rover so it doesn't crash into it, and then it will begin to explore Jezero crater. This is another painting that I produced showing the Perseverance Mars rover on the surface of Mars in Jezero crater that it's going to be exploring beginning hopefully on February 18th of 2021. And it has a lot of things that it's going to study, but one of them is the possibility that there existed water upon over this area within the crater billions of years ago, approximately 3.5 to 3.8 billion years ago. Now, this is another painting that I produced of the Jezero crater, what it may have looked like approximately 3.5 to 3.8 billion years ago when there was water over its surface. Now, at this time, at this distant time, 3.5 billion years ago, we believe, planetary scientists believe, that the atmosphere of Mars was a lot denser and it could contain water over its surface. And so this is a possible lake that was at over this area, over this crater, because images now obtained by orbiters show these channels or canals leading into the crater and that are believed to have been produced by running water. So this is one of the primary missions or objectives for the Perseverance Mars rover.
Again, that is so beautiful and something just to contemplate. So guys, when you look at this, think about the research that Carlos had to do, had to think about and dream about, that if water existed 4.5 billion years on Mars, what did it green the hills of Jezero crater? What did that look like? What made it go? And so a lot of research goes behind what he's talking about. As you can tell, he's very knowledgeable about everything he's speaking about. So think about that as your art meets your science, that it isn't like, it's all rather based on knowledge acquired and gained. And Carlos, you reminded me of something. I had a second grade teacher that was very discouraging to me about my art. And I think it was like, I wonder now if she had kind of even kindly just, oh, keep going, you know what I mean? But I think I took her words so much to heart that I was like, oh, I can't do that. But it is all a process of practice and study and a discipline to do it every day, correct?
That's correct, Janet, because I didn't begin making art or drawings or paintings at this level when I started. I needed to practice many times. As many successful paintings or drawings that I made many other unsuccessful drawings, and you have to persevere and be patient, and you will notice over time that your drawings will improve. If you were to sit down in your kitchen table and just pick a regular object in the kitchen and put it on the table, and if you were to sit there and draw it every day over a period of weeks, you would notice an improvement in your art if you're persistent. But you have to be very dedicated and you have to persevere.
Okay.
And you have to practice and do the work. Yeah.
Tapa Sweeney has a question.
Go ahead.
Unmute yourself, Tapa Sweeney, and ask the question.
That painting is so amazing, and I was just thinking that sometimes there are things that we imagine in our head, and I wanted to ask you, how do you manage to take that picture which is inside your head and accurately display it on another sheet of paper, because this is just so beautiful.
Well, as Janet pointed out earlier, you have to do a lot of research. You have to do a lot of studying, and you have to know the subject that you're trying to draw or paint. In this case, it's the planet Mars. In this case, it's a crater that used to have water in it. And so I research and try to get as much information as to what the crater looks like, what the walls of the crater look like, what the planet may have looked like 3.8 billion years ago. And I also look at images of similar looking places on the Earth. So I put all that together, and I come to this representation of what I believe the crater looked like at that period of time. But it's research and try to get as much information as you can. You have to apply all the principles of painting and landscape painting and things like that. But that comes with time and practice. And I think that most people, or most everyone, can accomplish this. This is a painting that I did of the inner moon of Mars named Phobos, Fear or Terror. And Mars has two small moons, an inner one called Phobos and an outer one called Deimos. And if you were orbiting the inner moon Phobos, this is what Mars, the Phobos and Mars would look like if you were orbiting it at the time. And the strange thing about Phobos is that it orbits so close to Mars. It's only a few thousand miles above the surface of Mars that this moon, this satellite, rises in the western sky of Mars, and then 4.5 hours later it sets, and then it rises again in the west, and this happens twice a day on Mars. So if you were an astronaut on Mars, then you would be able to see the moon rise and set twice in a Martian day. And because the moons are so small, you cannot see the moons if you're above 78 degrees latitude on Mars.
Oh, I did not know that. That's awesome to know.
Yeah.
Oh, Osiris Rex.
This is a painting that I produced recently of the Osiris Rex mission, the spacecraft of NASA and JPL. It's orbiting an asteroid located between Mars and Jupiter named Bennu. And ironically yesterday, it touched down and hopefully obtained a sample of the surface of this asteroid in the asteroid belt of the solar system. And it had been orbiting, the spacecraft had been orbiting Bennu for some time, since December of 2018. But then over time, it got closer, and then it did some practice runs. And finally, yesterday, it dropped down to the surface, touched down on the surface for approximately 5 seconds, and hopefully obtained a sample of at least 60 grams or a little bit over 2 ounces into its receptor. And if it did, it will put it back into the spacecraft and eventually return those samples to the Earth.
Yeah, it was quite exciting. We actually, with this class here, we stayed online and opened up the live stream from NASA, and to hear them like, we are go for tag. I don't know about you guys, but I was weeping in front of the kids just because there's something so amazing about humans that can conceive the math, the trajectory, the mapping, the coding that has to go in for these kinds of amazing events to happen. So it was exciting. It'll be nice. It'll be fun to see if when they do take it through that maneuver where they weigh it and find out if they do have enough material in there.
That'll occur on October 24th, when they'll do a spin maneuver to find out. And if necessary, they can go back. They have 2 more nitrogen tanks to do 2 more sample missions if necessary. But hopefully they obtained enough a sample to not have to do that.
Oh, even better. Look at all that blowing apart, that nitrogen gas, blowing apart those little particles.
Right. And if you were standing right next to if you're able to stand next to the Osiris Rex spacecraft as it was obtaining the samples, this is what I believe you would have seen as the nitrogen gas blew out and suctioned in particles. They're hoping at least 2 centimeters in diameter into the receptacle, and we'll find out soon if we got enough material from this what they call tag, or touch and go tag.
And guys, really listen to Carlos today, because One of the things that I think from hearing you this morning to this afternoon, you think a lot about if I am standing here, if I have the visual. So it's like that seems to impact. It seems like you're almost putting yourself into your art, going, if I were capable of witnessing this with my own eyes, here's what I would see. Is that I mean, that sounds like you've said it several times. And I'm going, that's really, you're forcing our perspective to be as if we're standing there watching the event happen.
That's true, Janet. And I mean, that applies to every artist. And Tim would tell you the same, is that it all depends upon your perspective, because the same object will look different from different perspectives. And you try according to physics and the angle formulas and all these things, that tells you what the object may appear as from a certain distance and in a certain angle. So yes, perspective is very important.
Again, guys, science is math and art and all kinds of things, and art is as well a part using the math to think about this. Oh, what is this?
This is the sample return capsule that was going to be put into the OSIRIS-REx spacecraft if we obtained enough sample, and then it's going to be released from the spacecraft and hopefully land over the western part of Utah in the United States on September 23rd, 2023. So hopefully on that date, we will get the sample return capsule, and hopefully the material from Bennu will be inside that capsule.
Oh, I cannot wait. Super exciting and more science to do.
Yes. Next, we come across the fifth planet, the largest planet in the solar system, Jupiter, the king of the gods. And as you can see, it's got these bands and white bands and colored bands across it. In the center, you see the famous great red spot that's about twice the size of the Earth. It's a huge anticyclone, similar to a hurricane, that's been in existence for almost 200 years, possibly 300 years. And Jupiter is a gas giant. It's not like the Earth. It's not a rocky planet. It's a gas giant made up mostly of the most common element in the solar system, hydrogen, and helium, with other trace gases as well, including a small amount of water vapor. But there's no solid surface on the planet. There is a large core, but you have to go way into the planet to reach the core. And you go under extreme pressures and extreme temperatures as well. But it's a gas giant planet. This is a painting that I produced of the Juno spacecraft that is currently orbiting the planet Jupiter in a polar orbit over the poles. And it's studying the atmosphere of the planet. And so far, it's returned incredible kaleidoscope images of the atmosphere of Jupiter. And you can look it up on the Juno website, and they're fantastic images. And we're learning a lot about the interior of the planet, because it has special instruments that can penetrate deep into the planet. And this is the Juno spacecraft flying over the Great Red Spot over the southern hemisphere of the planet. And this Great Red Spot, twice as large as the planet Earth, and it's been around for hundreds of years.
Excuse me?
Yes.
Uh-huh.
If you hadn't told me that last one was a painting, I would have thought that was a picture.
That one right there?
Yeah.
Yeah, he's so good. I know.
Well, thank you. Thank you. Now, this is a painting that I produced of the Galileo atmospheric entry probe that entered the atmosphere of the planet Jupiter on December 7th of 1995. And I was actually fortunate to be at the Jet Propulsion Laboratory as a guest of the planetary scientist Glenn Orton, who invited me to be there for the probe entry. And I was able to see the data as it came in back in 1995, as the atmospheric probe entered the atmosphere. It entered the atmosphere of Jupiter over its equator, and it lasted for approximately 78 minutes, and until it reached a pressure of 22 bars or 22 atmospheres. And so because the pressure was so high, and the temperature was very high. It was 300 degrees Celsius. The probe disintegrated at that point, but
Wow.
it lasted for approximately 78 minutes, and we obtained information about the atmosphere of the planet Jupiter. And as a side note, when I was having lunch with that astronomer, Glenn Norton, we went to the cafeteria there at the Jet Propulsion Laboratory in Pasadena, and we were just sitting down, and all of a sudden, a group of astronomers come by, and they sit down with us, and they were friends of my friend. And all of a sudden, next to me, this gentleman starts to talk to me, and he starts talking about amino acids on the rings of Uranus. It turned out to be Carl Sagan.
Oh, wow. Oh, wow.
So I was having a conversation with Carl Sagan about amino acids on the rings of Uranus.
Oh, too good.
Yeah.
Too good.
Now, this is a painting of as an eruption of a volcano, sulfur dioxide volcano, on one of the inner Galilean satellites of Jupiter. Now, the Galilean satellites were 4 satellites, Io, Europa, Ganymede, and Callisto, that were discovered by the Italian astronomer Galileo Galilei in 1609. And this is the innermost of those. And this one is about the size of a little bit bigger than our moon. And it's the most volcanically active body in the entire solar system. It has over 400 active volcanoes on it. And it's the yellowness you see is because the material is mostly sulfur and sulfur dioxide. So it even has a faint atmosphere of sulfur as well. But and the reason that this moon satellite is so volcanically active is because as it orbits Jupiter, the intense gravity of Jupiter pulls it back and forth, and it heats up the interior of the moon, and that's why it has the volcanic activity. But if you were able to stand on the surface of Jupiter, of Io, looking towards Jupiter, this is what you would see.
Beautiful.
The planet Saturn is the most beautiful of planets with its extensive ring system, another gas giant planet, mostly hydrogen and helium, and the ring system that's been in existence for millions of years. They believe that the ring system was caused by the breaking up disruption of a moon that got too close. It's made up mostly of ice particles, dust-sized or up to boulder size, and that orbit the planet at different rotation periods. And that's why we see the different rings and the division between the rings. But it's actually made up of individual particles, and it's not one solid object. And it's a spectacular object. The detail of the rings that I just mentioned, composed of individual particles, dust size to boulder size, that orbit the planet at different speeds, different rotation periods. And you can see the divisions within the ring system. And the images returned by the Cassini orbiter and the Voyager spacecraft were just spectacular images showing how beautiful the ring system is. And if you get a chance, look at the image from the backside of the rings, because the backside of the rings are illuminated differently. So it even looks just as spectacular from the backside. This is a painting that I produced of the surface of the largest satellite moon of Saturn, Titan. It's the second largest satellite moon in the solar system, and it has an atmosphere that is more extensive. This is a moon. This is not a planet. It has an atmosphere that is more extensive than our own Earth. It's 1.5 times as massive as our atmosphere. Now, this atmosphere is mostly nitrogen, where our atmosphere is mostly nitrogen, but oxygen as well. And they've even compared the atmosphere of Titan to a primordial Earth atmosphere. And so we need to investigate it. And we're sending a probe called the Dragonfly in the next several years to study Titan in detail. And it's a quadcopter that will explore different areas of the satellite. And it'll explore the surface. It'll explore the lakes on Titan, which are made of methane and ethane. And it hopefully will return spectacular images of this incredible satellite.
And guys, on Titan, because the atmosphere is so thick and the gravity so low, if we go there as humans, if we could go there as humans, a human could don a pair of wings, you could flap your arms and you could fly about because the atmosphere is so thick and the gravity so low. So that'd be pretty cool. And it has lakes of methane and ethane. So if we could get there, at least we'd have rocket fuel for the trip home.
That's true. That's true. But I don't know if they'll make you have a pilot's license. So
that's right. I'm just going to fly over here, guys.
You probably won't need a flying license if you can just fly with your arms.
Just drive with your arms. I like it, Sean. I like how you're thinking.
Yeah, that's true. Great exercise. But this is a painting that I produced of Saturn as visible from one of its small satellites, moons, named Enceladus. And it's not that large of a satellite. It's about 300 miles in diameter. And the reason this moon is so special is that we've discovered geysers of water vapor erupting from its surface, especially over its south pole. And having geysers of water vapor means that underneath the ice, because the surface is covered by ice, beneath the ice is an ocean. And if it has an ocean beneath it, then there's the possibility that life may exist in that ocean. So that's why Enceladus, as well as going back to one of the Galilean satellites of Jupiter, Europa, we believe that they have oceans beneath their surface and that they may harbor life. In the painting, you can see these green birefringent fluorescent objects at the bottom of the painting. And I speculated that those might be similar to algae, and that could be a life form that may exist over this moon. This is a painting of the outer planet Uranus, visible from one of its moons, its satellites named Miranda. Now, Uranus is a gas giant like Jupiter and Saturn that's mostly made up of hydrogen and helium and methane. The methane is what gives it that color of Uranus. And it's also tilted on its side by an actual tilt of 98 degrees. Now, we're not sure why this planet is tilted over so much, but it may have been from an impact that occurred from a large object billions of years ago that literally flipped the planet on its side. So that's a very interesting thing. And if you notice, it has dark rings. It has rings, and instead of being oriented normally, they're oriented up and down. That's because the planet is tilted. And so that's what it would look like from Miranda. Now, this is a cliff on that satellite. It's not a very large satellite, but it's got this giant cliff that's 5 or 6 miles in height above the surface of the satellite. And the name of this cliff is called Verona Rupes. And if you were to jump, brave enough to jump off the edge of the cliff, because of the low gravity of the satellite, it would take you minutes or almost half an hour to reach the surface. And if you were able to protect yourself with enough airbags or some kind of protection, you may actually survive. I wouldn't recommend it, but it's
but a good science experiment if you've got enough padding on or something.
Right, but it's just amazing that this tiny satellite, this moon, has a 6 mile high cliff, and they believe that it was formed from the tectonic activity, or actually they think that the satellite could have been broken up into pieces, and then when it came back together like a abnormal jigsaw, it produced this cliff. So they really don't know why.
Gorgeous.
Another outer planet, Neptune, another gas giant, the eighth planet. It's also made up of hydrogen, helium, and methane. And this is a painting that I produced from as the viewpoint of one of its inner moons, small moons, called Hippocamp. It's about 65,000 miles away from Neptune. It orbits Neptune in about 23 hours. And if you were orbiting near that small moon satellite, this is what Neptune would look like.
Gorgeous.
The largest satellite moon of Neptune is called Triton. Triton. Now, and when the Voyager 2 spacecraft flew by Neptune in 1989, it discovered these erupting geysers over the surface of the moon Triton, and they're dark. There were dark material coming up, but it was very, very exciting to discover this. And also the surface of the satellite was called the cantaloupe terrain because it looked like a fruit cantaloupe. So it's a very interesting thing. So hopefully in the future, we'll be able to send an orbiter and possibly landers to land in this interesting satellite to better understand what causes the geyser activity and the composition of the surface.
And again, guys, where there's water, there's often life. And we do, even at the lowest points in our oceans, there are these hot little vents, and you would think nothing could survive down there, but scientists and marine biologists do know that life exists there. So anytime when we talk about water on another planetary body, we go, what else is there?
Yeah. You know, about water, NASA actually says if there's water and there's a chemical reaction, and a chemical reaction usually also produces heat, then there is life. That's not a question, that's a certainty. Even if we haven't found it yet on anything, these two things are enough to know that life is there. It's as simple as that.
Mm. And look at Pluto.
This is an image of Pluto obtained by the New Horizons spacecraft as it flew by Pluto. It's a dwarf planet on July 14th, 2015, at a distance of 7,800 miles, 12,500 kilometers. And it obtained incredible imagery of this dwarf planet, far beyond what any planetary scientist expected. And you can see at the bottom of the disk of Pluto is Sputnik Planitia, which is called the heart of Pluto because it's got a heart shape. And it was visible from far distance also. But they've discovered a lot of interesting features over the surface of Pluto. And it's mostly nitrogen ice. The temperature on Pluto is so cold that water behaves like a rock.
Wow.
Like a rock. So the other substances like nitrogen, they have melting points that are lower, and therefore they can exist in a liquid form under certain conditions. But water is like a rock there. So, but that's something that hopefully a future lander or an explorer, an orbiter can determine. And this is a mountain called Hillary Monts. It's about 2.2 miles, 11,000 feet in elevation at the edge of that heart of Pluto, Sputnik Planitia. And you can see how magnificent it looks in comparison to that plane. And the other thing that you notice is that the atmosphere is bluish. And that's something that we discovered when we got there, that the atmosphere of Pluto, even though it's very tenuous, very, very thin, it is bluish in color.
Gorgeous.
Now, this is a painting that I produced of Pluto as it looks like from its moon, Charon. Charon is a very interesting satellite. It's over half the diameter of Pluto. So Pluto is actually considered a double planet because its moon is over half the size of the primary planet, which is Pluto. So it's actually considered a double planet. It's a very interesting object as well, because the Earth's moon is the second other object that's big in comparison to its planet, parent planet, but it's only 25% the size of the Earth, whereas Charon is a little bit over half.
Hmm.
Now, as the New Horizons spacecraft flew by Pluto on July 14th, 2015, it went into the shadow of Pluto and looked back at Pluto and to look and study the atmosphere of Pluto. And this is a painting that I produced before the flyby of what I believed it would look like. And ironically, it turned out to be accurate. So it shows the thin rim of the atmosphere surrounding the planet and the bluish color as well.
Again, guys, he had done enough research. He knew what it could look like, drew it, and then his kind of hypothesis of what it could look like ended up being pretty darn close to the real thing. So amazing.
This is a painting of the Kuiper Belt object. This object is about 45 times the Earth Sun distance. Its name is Arrokoth. It used to be known as Ultima Thule, but now it's known as Arrokoth. And it's about 22 miles in length. The smaller lobe on the left is about 5 miles, and the other one is about 15, 16 miles in diameter. And they believe that they were in many millions, billions of years ago, there were two separate objects that came together slowly and then ended up connecting to each other.
Again, beautiful.
Now, beyond the solar system, we've been able to discover with satellites orbiting the Earth and from the Earth, the ground, planets orbiting other stars, what are known as exoplanets. Now, this is a painting of Proxima Centauri b that's orbiting the nearest star system to the sun, to the Earth, Alpha Centauri, which is a triple star system. You can see the two brighter stars to the right, and the small third star is a red dwarf star called Proxima Centauri. And technically, Proxima Centauri is closer to us than the two other stars. And that's why it's called Proxima, which is Latin for near. And it has an exoplanet orbiting it, we believe. And we're not sure that it could contain life, but it's a possibility if you're located within certain portions of that exoplanet. But it's something that hopefully future probes will be able to better understand, including the James Webb Space Telescope that may be able to see some spectroscopy or some imagery from this area. A painting of the surface of Proxima Centauri. If you're standing on the surface of Proxima Centauri b, you would see the red dwarf star Proxima Centauri rising. And this is what I believe would be a scene if you were located at over the surface of that exoplanet. Mm. Now, there may be life elsewhere in the universe. It may not look anything like life we have here on Earth. It may most probably be carbon-based like we are, but it could also be silicone-based as well. This is an amphibious creature that I drew swimming in a lake water over the surface of an exoplanet. And it's just exciting to think that life could exist elsewhere in the universe. And this is just a possibility that I dreamed of. And this is a painting of an exoplanet orbiting the famous Pleiades, the Seven Sisters. And you can see the reflection of the Seven Sisters in the lake of this exoplanet. And there's planets and moons in the universe that their beauty doesn't even compare to what I could possibly or any artist could paint. But it's just exciting to think that there's these objects or planets out there. Now, to get into or to start into space art, you don't need fancy equipment. You don't need a supercomputer or something like that to start. Although my paintings that I've shown have been produced on a computer, I started drawing like everyone else, and probably Tim as well. using a pencil. You can use a regular pencil, the graphite on the left, and or mechanical pencil, and you can use that with a drawing pad. And as Janet mentioned earlier, you have to practice, practice, and practice. That's the only way. That's the only way to get really good at art, at drawing or painting. And this is a tool that you can use to produce the moons or the planets, and it's a template, and it shows different size circles that you can mark out with a pencil or a pen. You can also use brushes using the materials. It can be ink, it can be watercolor, it can be acrylic, it can be oil, whatever media you want to use, you can do it. Now, if you want to create art on a computer, it would be helpful to use to use a graphics tablet, such as this Wacom graphics tablet. But any graphics tablet is useful as long as you can connect it to the computer that you're using, and you use it along with software. And there's a pen on the side there that you actually draw on the surface of the graphics tablet. And what you draw on that surface shows up in the software program on the computer. And you can also use graphics tablets like the iPad, the Apple iPad, or any other tablet. And you can make a space art or any kind of art on these. But the important thing is to have fun, to enjoy what you're doing, to don't give up, practice, 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 and you'll be able to produce excellent art that you'll be proud to show to everyone.
Ah, bravo. So beautiful. Before we go to questions and everything, oh, I know you've got lots of comments like, and yes, Salsa, we will watch your animation. We will have 2 artists take a look at your animation at the end of things. So next up is Tim Gagnon. I'm going to bring up Tim. Tell him a little bit about what you do. He has designed so many space patches, and one of the ways that that has happened, it's like, again, you had a conversation, said something that you wanted to do, and lo and behold, somebody took you seriously that, hey, let's call that kid up, right?
Well, almost that good, but it took a while. Back in the 1970s, my father and I were invited to the launch of Apollo 17, and it was at that launch that I saw the mission patch and learned that it was designed by an artist who had no formal connections with the space program. The artist's name was Robert McCall, and he's an amazing talent, has done many works. If you've been to the National Air and Space Museum, the very large murals there are his work. And I figured if he can do something like that, then that's how I could possibly one day contribute. All of the mission patches for Apollo and Skylab were already approved to that point. But during the summer of '73, the second increment crew, Alan Bean, Owen Garriott, and Jack Lausma, their spacecraft developed a leak in the reaction control systems. So NASA began planning for a possible Skylab rescue mission. So I did some research and found out who the crew members were, Vance Brand and Don Lind, and I created this artwork that you can see here, and I mailed it to Vance Brand. And he responded a couple months later that he appreciated my effort, but looks like NASA had come up with a workaround and the mission wouldn't be necessary. Fast forward to 2017, I meet Vance Brand and his wife at Space Fest in Tucson. And I go up to him and I said, "Sir, you have no reason to remember this, but in 1973, I sent you artwork for the Skylab rescue mission." His wife spoke up and said, "I know exactly where that is." And they mailed me my original art that I hadn't seen in 44 years back in time for my birthday 3 years ago. So that was pretty cool because I didn't remember what media I had used. It turns out that Crayola was the media of choice to this 16-year-old artist. I always continued to try. I wrote a shuttle cruise and often received replies that were very encouraging. They wished me well. They told me to keep trying, but they had already chosen another artist. And many times since then, that artist was Robert McCall again. So finally, I wrote to him in 1982, and I said, I would like to get some insight on how I can improve my work. And he sent a nice, warm, handwritten note. He actually did a sketch on the envelope that I still have framed in my office. So I have an original McCall. And I used that advice, even though it wasn't what I wanted to hear in 1982. I use that advice today. Work hard, come back from inevitable failure with courage, and study the great art of the past. And basically, it was a note to keep trying, keep persevering. So finally, in 2004, I contacted John Phillips, who was the flight engineer for the Expedition 11 mission to the space station. He flew along with Sergei Krikalev, and he chose me to design the Expedition 11 patch. And it took about 3-4 months of phone calls and emails back and forth. You'll notice the swirl of the flags here. Sergei Krikalev was a member of the first space station crew 20 years ago next month. And they had used the radio call sign of Alpha. Well, this is a stylized image of the Greek letter Alpha using the flags. And they were originally intending to have a third crew member, but when the foam came off of Discovery on STS-114, the third crew member was dropped from 121, which would have been the next flight a few weeks later. And so Expedition 11 only had 2 crew members, but they were still on board station serving when Discovery arrived with Eileen Collins and her crew on the return to flight mission. After that experience, which was the realization of a lifelong dream, I received a email from a surgeon, orthopedic surgeon in Madrid, Spain, by the name of Dr. Jorge Carts. And he told me of his interest to one day create a mission patch as well. And I said, you know, Jorge, I don't know if that opportunity will ever happen again. But if it does, why don't we collaborate? And so when we were contacted by the STS-126 crew, I researched the mission, Jorge researched the mission. We both created a first draft design, and we emailed both of them to the crew. The crew liked some of what Jorge had done. They liked some of what I had done. And so over a period of a few weeks into almost 3 months, we would tweak the design based on crew feedback after their weekly crew meetings, and eventually reached that point of a design that they were happy with and was approved for the official mission patch. The 126 crew talked to the 127 crew, and they talked to the 129 crew, and so forth. So over the next decade or so, we were fortunate enough to work with 5 shuttle crews and 14 space station crews, helping them design their mission patches. And as you can see from the slide here, each crew has a different personality. Some like the design to be busy, some like it to be very simple. The Expedition 23 crew patch that was moving into the center of the screen there, this was a Hail Mary pass. We had worked with astronaut TJ Creamer he was our point of contact for the crew, and Oleg Kotov was the Soviet commander, or the Russian commander. The system had changed by that time, and it just did nothing we did seemed to grab their attention, or so this design that you see on the screen was a last-ditch attempt to try to come up with something they liked, and they did. I can't imagine what would have happened if Oleg had said "niet" to that design, because I was fresh out of ideas.
But you know, it's so clever how you made the Roman numerals the flags of the countries. Yes. That's beautiful.
Yes. And when we first submitted the design, I had the flags for Russia wrong. I had the red, blue, and then white stripe. And when you take a flag off the pole and you display it vertically, you take it and you rotate it so that the like the US flag there, the stars are at the top and not the bottom. So I had done that with the Russian flag. I basically displayed it upside down, and it wasn't caught by NASA graphics and NASA management when it was approved. And they had to make a last minute change before the thing went into mass production.
Hey, talk to them about this STS-129. I love the stories and this design shape. You had to get a bit, they had to get a bit of approval because it looks a bit, is it taller than most?
Yes, it was actually, I think, 5 3/4 inches tall, and the specifications call for nothing bigger than 4.5 inches. But they countered that, you know, the shuttle program is ending. We're running out of opportunities to fly. So, and this is a design we would really like to have. The diamond is, if you'll see it, it's double bordered, and it has it represents the 2 external pallets that the Atlantis crew attached to the structure, the truss structure on the ISS. And the flag, the colors of the flag form the astronaut symbol, because this was an all U.S. crew, which is another reason why you see the continental United States at the bottom. But they didn't want clouds over the Cape on the patch. They didn't want a weather delay, and they wanted to see Clear Lake in Houston without any cloud cover as well. So we learned that astronauts are almost as superstitious as baseball players. When we were almost done with this design, the stars on the patch represent the children of the astronauts. They asked us to add 1 more star, which we did by Butch Wilmore's name. And, you know, we didn't question it. You want another star? We'll give you another star. That's no big deal. And you'll notice that the patch I'm holding, the sun has rays that are pointy, and that the artwork on the screen has a gradient sun. Well, this patch had 2 official versions. The radiant sun you have on the screen represents what they could use for printing and TV and so forth. The embroidered design had to have a different type of sun because you can't embroider gradients. So anyway, they launch. The first the mission begins when they dock at the station, and the day that Randy Bresnik took his first spacewalk, his daughter was born. And the station and shuttle crew hosted a baby shower for him on board the ISS and presented him with a STS-129 onesie that I believe is now on display all these years later at Space Center Houston.
That's so great. But you said this morning the stars all represent their children.
Yes. Yeah, and the meanings in the patches are different for every crew. That crew wanted the stars to represent each of their children on the patch.
Tim, could I request that you talk about the Crew 30, because the Dutch astronaut André Kuipers is part of that.
Oh,
and
yes.
I would love to hear about this.
Yes. Expedition 30, we almost didn't get an opportunity to work on this because Dan Burbank was the increment commander, and he had approached his daughter about doing some artwork. And I don't know if it was because of college or some other commitments, she wasn't able to. But we obviously told Dan that, if she wants to weigh in on the design and provide feedback, we're open to hear it. On this design, we wanted to show, and this was an ambitious design. It worked pretty well in print, but not as well in embroidery. I wanted to show the earth at night lit up. And the 3 X's is the Roman numeral for 30, of course. And then the solar arrays from the ISS balance out the opposite end of the patch from the Roman numerals. And then, it was supposed to be a bit of a unique image of the ISS orbiting the Earth in a different way. And we were actually told that some people felt that the font size for Burbank and the 2 Russians on the top of the patch were larger than the font size for Andrei Kuipers and Don Pettit and Kononenko. And they're exactly the same size. I see what they mean when they say that, but the letters are exactly the same. But it was a fun, Dan was born in Connecticut, and I was as well. And we got to meet him a few years ago, and he presented Jorge and I with the flown patch montage from Expedition 30. But it was great to participate in that.
Is it just an optical illusion? Is that just the way that?
As far as the name, well, if you look at Kuipers and you look at Burbank, you would think Burbank is a larger letter, a larger font, and they're exactly the same size.
Very interesting. All right. What other patch do you want to talk about here? They're all so fantastic.
Well, I mentioned before that when I received gracious letters turning me down from astronauts over the years, that they had chosen Robert McCall to design their patch. And, quite honestly, if I had a chance to have Robert McCall design my patch, I would too. The Discovery, the 133 crew, when they were chosen, they were going to be the final shuttle mission of the program. 134, 135 had not been manifested yet. So the 133 crew naturally turned to Robert McCall to create a design for their patch. Perfect bookends. He did STS-1, so it made perfect sense for him to do the last shuttle mission. He had painted 2 watercolor draft designs, and I've seen them. They're absolutely beautiful. And he passed away the day after he mailed them to Johnson Space Center. He was 90 years old. The pilot on STS-133, Eric Bowe, was the same gentleman that was our point of contact for the 126 mission patch. So he said to the crew, why don't we just get Tim to finish this? And Robert Perlman from collectspace.com wrote up a wonderful story of the entire affair. And you can reach that story by internet searching Robert McCall STS-133, and it's going to be one of the first things that come up. If you look close at the design, if Janet, if you can zoom in on that one, the 6 5-pointed stars at the top represent the crew, and the gold star next to the pilot's window represents Robert McCall. The tiny gold stars on the opposite side under Steve Lindsay's name are for Jorge and I. And we did that deliberately because we felt that our contributions to the artwork are that dissimilar. Robert McCall still created the basis of the patch. As a matter of fact, that final image of the shuttle is his sketch, rough design of what the orbiter would look like. And we showed the crew a polished version of that, and they preferred the McCall sketch. If you look at the smoke plume, artists have been adding their initials to patches, mission patches, since the Apollo days. And we added a T and J to the plume. And we figured, well, could be our last mission patch. We'll take a shot at it and see if it's still there when they release the artwork. When it was released and the T&J were still there, and if you'll want to scan down to the bottom of the patch. There you go.
Mm-hmm.
When the T&J were still there, we found out a few weeks later that the graphic artist that took our work and turned it into the product suitable for TV and print and embroidery and everything else was named Terry Johnson. And so we lucked out on that one. I'm sure Terry tells a much different story. But the T&J were important not only for Tim and Jorge. My daughter's name is Trisha. My son-in-law's name is Jason. My grandsons are Tyler and Jack. So I really wanted that TJ to stay in there.
That's fantastic. Any questions, guys?
Well, Janet, I just want to point out and thank Tim for all his wonderful patches, that each one of them represents history. And it's very important and a great accomplishment for Tim and Jorge to have done what they did.
Thank you. Thank you very much.
Yeah, both you guys. Yes, Lucas?
I got a question.
Sure.
Did you make the patch for Terry Vert's first mission?
For who?
Terry Vert's.
Actually, we submitted a design for STS-130, and they did incorporate a design that uses the cupola windows like we did, but that was done by Steve Robinson, who was a member of that crew, and Steve is also very artistic. So while we attempted to design Terry's patch, we didn't.
Good question, Lucas. All right. Yes.
I have a question,
Sure.
but I need to go really quick.
Sure, baby. Go ahead, Andrew.
I think he said he needed to go and do something quick.
Oh,
I had the impression that Brian was waving, with his hand. So it might be that Brian and Wyatt had a question. I don't know.
Brian, do you have a question, dear?
Oh, it might be that they left.
I gotcha.
Because it's 25 minutes or it's 20 minutes after. And they probably were saying, we need to go. Yeah.
True.
Understood.
Well, if any of the students have questions that we don't get to answer.
Back.
Ender is back. Okay.
Okay, so I would like to know if you've done the patches for STS 65, 70, 83, or 90.
Or 90.
Yeah. And
all beautiful designs, but not mine. STS 126 was the first patch that I was successful in flying in the shuttle program. Now, I designed patches prior to that, including the first proposed mission from Vandenberg Air Force Base, but those other missions were canceled.
And Andrew, tell him why you're
STS 90 is one of my favorites, by the way.
And why did you want to know that? There's someone on these missions, or are they from your city or your state? Why did you ask?
Someone muted me. So STS 65, 70, 83, and 94 all have astronaut Don Thomas on them.
Okay.
So they're all of Dr. Don's missions. So just wanted to know.
I've met Don Thomas. He's a really nice guy. Loves pizza too.
He loves that story. Guys, we'll take a few more minutes and thank you for the generosity of your time. Talk them through this Artemis patch, which again, because they're the Artemis generation and this beautiful Moon to Mars patch, I just love it. Love it.
Are you going to put it up on the screen?
Oh, is it not showing up? Hold on one more time. It looked like it was there. Again, I was seeing it. Sorry. There you go.
All righty. Well, since I was a child of Apollo and I was inspired by all the beautiful artwork and all the amazing engineering and so forth, I wanted to create something, attempt something as impressive for the Artemis generation, because my grandsons are 13 and 9, and these are the missions they're going to see as they grow up. And so Artemis is in mythology, is the sister of Apollo. She's the goddess of the hunt, the goddess of the moon. And I didn't want to show her as some dainty princess type character. I wanted her to be powerful. I wanted her to be fierce and brave. And so I've illustrated her pulling back her bow to fire it towards the future, towards Mars. She's standing in front of the moon because she's the goddess of the moon. And that's our first step. As we travel to Mars, we're going to test out the infrastructure on the lunar surface. And I hope this time we establish a Antarctic science base similar to what we have in the bottom of the Earth, the South Pole. But all the infrastructure that we're designing and building for the Artemis missions to Mars, we're going to test on the moon. And so that's why that's there. The patch, the uniform is kind of inspired by Wonder Woman. The colors are different. She has the red on top and the blue below and so forth. But red, white, and blue are colors used in many of our partners' flags. So that's why, but the Artemis program is led by the United States. So that's why I've painted her in a similar outfit. I could have put, white robes like the statues in Rome depict Artemis, but I wanted to show something more powerful, more impressive. And
one thing that I think you all need to know, the statues that we see from Rome or Greece, they're white now, right? They're always this white marble.
Yeah, it's the marble.
They
right.
actually were painted in the days. And, you can see that sometimes if you get really close to, to one of these statues of the Parthenon or a Roman statue, that they were painted. So their clothes wouldn't have been white. They might have been many colors, but it's just the age that has taken all these colors from us. And we can see it, for instance, that the eyes were also painted, and then if you go really deep into, and you can see. So the fact that this is probably far more realistic, bright colors for a dress of of a Greek woman than all white.
It's just gorgeous. And thank you guys so much for your time today. I'm going to show this other patch. I had it up, I think. Hold on, let's see. If I can find it. We are close to time. I tell you what I'm going to do. I want to honor a student's request. Salsa, are you still here? And you want to show us your animation, because Salsa is quite good at her art and everything. So
excellent. Love to see it.
Salsa's here.
All right. So Salsa, do you want to share from your computer, or do you want to tell me where to go to that on Scratch? All right, I'm getting a couple of messages. Okay, so she put it in the link in chat. And you should also see some really beautiful stuff that some of these other artists here. So the singing criminals, who knew? Let's see here. All right, so again, fantastic art, and please listen to all the great things that, let's see. Do you guys all see this?
Yes, I do.
Awesome, I know. So here we go, Salsa. This is.
So, do you recognize any of these men?
I was hiding in the bathroom stall, so I didn't see his face, but I heard him. He was singing along to the music at the bar.
Do you remember what he was singing?
I think it was that song, I Want It That Way.
Backstreet Boys, I'm familiar. Okay. Number one, could you please sing the opening to I Want It That Way?
Really? Okay. You are my fire.
Number two, keep it going.
The one desire.
Number three,
Believe when I say.
number four,
I want it that way.
tell me why.
Ain't nothing but a heartache.
Tell me why.
Ain't nothing but a mistake.
Now number five, I never wanna hear you say.
I want it that way.
Oh, chills, literal chills.
It was number five. Number five killed my brother.
Oh my God, I forgot about that part.
That's pretty funny.
That's excellent.
Oh, I got to turn that down. Hold on 1 second. Pretty funny there, Salsa. So using your art in multiple ways to entertain. And again, here is, remember that tomorrow is Science and Tell. You got 5 minutes to show and tell and give me some science, and you can do it, you know, any way you want. Also, here's a challenge. We'll try to finish this up by next Thursday. You must design your own crew patch, and you must do your research, and you must look up Tim Gagnon. Then you must design and draw some space art. You got to do your research. Find that planetary place that you want to draw and imagine. And who knows, again, Carlos over there seems to have a crystal ball and draws stuff that happens prior to an actual picture being revealed of these places. So I would like for all of you to unmute and say a big thank
Before
you to
they,
these fabulously
Janet,
talented people.
Janet, before they do,
All right.
let me just offer a couple of quick tips.
Okay.
When they draw their mission patch, don't make the circle or whatever shape they choose any larger than 8 inches in diameter, because that can lead you to think that you actually have more room than you do. And also at that scale, at 8 inches, your letters need to be a 1/2 inch high, because the final patch at 4 inches or whatever, the letters would have to be a 1/4 inch high to be embroidered clearly. A lot of people make, you know, a fantastic design, but then they have their names or their text very, very small. Yes. So if you keep that in mind, and also no more than 8 colors.
Yes. Yes. Oh, no more than 8 colors.
Yeah. And Janet, if I can interject here,
sure.
For the space art, I would suggest that the person not make the drawing too complicated. Like if they wanted, instead of drawing multiple craters, I would focus on 1 crater or 2 craters, you know, to try to simplify the drawing of the painting. But, you know, be careful, you know, how much you try to include in the painting. I would start easy with something simple and then go from there.
Yeah. Oh, wait a minute. Taba Swinney has just told us something. You already have your Artemis logo done? We have to see it, Taba Swinney. Can you show us now?
Definitely. I'll just get it.
Right. Oh, you have it like already drawn. Okay, guys, you guys are being very generous with your time, but these kiddos keep impressing me. And good eyes, Catherine, she wanted to know what the Latin meant at the bottom of the Artemis patch. And so I put that in there.
I'll let Artemis answer that question.
Yeah, it says Artemis et Luna. So Artemis and, because ET is and in Latin, and the moon. And then at is to Mars. And Martem is, you know, it's Latin is conjugated. So this is the accusative. So that's the 4th form of the word Mars. And it's Mars, Martis, Marti, Martem. That's the way it's conjugated. So this is the form. That's why it says art at Martem, because the preposition at goes with the 4th. So that's what it means. So Artemis and Luna and the moon to Mars.
All right, Taba Swinney, talk us through this design.
Okay.
So while I was designing this, I wanted to incorporate everything that I thought of, and this over here, this symbolizes that no matter how many drawbacks we may suffer, we will keep moving forward. We will take a push from all of that and keep moving forward. Um, then the arc, the outer arc, it symbolizes the moon, and also the bow, and the inner arc, it symbolizes the earth, and so it symbolizes the earth and the duty and our duty towards our planet. Then the vertical line symbolizes the launch pad from which the mission will be launched. This is supposed to be the bow, and the fact that it is a perfect horizontal line symbolizes that we will have a uniform journey and that everything will
Beautiful.
be uniform. Later in the bow, there's this forward thing which symbolizes our need to go forward to achieve our goals. But I've also drawn this at behind, which reaches the earth, which says that no matter how far we go, we will always return back to our planet because this is where we began. And over here, as you can see, there are like two lines over here, and this kind of symbol. These two lines, they kind of symbolize that we come in peace.
Very nice.
Gorgeous.
A lot of smart detail in there. Excellent.
That's excellent.
Beautiful. Well, guys, we have had a fantastic day. Lots to think about. Please continue to think about how your art intersects with your science intersects with your art. And what I love about all the many speakers and experts that we have to come and speak with all of you, hear them when they say, they had a dream, they had a passion. They kept probably doing a ton of other things along their path to the thing that they loved doing, but they never ever wavered in what their hope to be doing was, and they found a way to mix both their talent and their passion and their love of space and mingle that all together. Yes, Lucas, what was that, baby?
I gotta leave you.
Go play.
Okay.
Are you playing soccer today or hockey?
Hockey.
All right, go do a good hat trick for all of us. Bye, everybody. Thanks so much for joining us. Thank you again for your time, fellas. Beautiful.
My